you just put kinetic energy final. Plus, does it have potential energy? What is the formula for the potential energy? mgy. And what is y in this case? So can you see that it's pretty much the same? So this is the pendulum. You have other pendulum questions there, probably. Question number 6, which is similar to the pendulum. It's a ramp, but works the same way than the pendulum. Question number 6. Question number 7 doesn't work the same way. It's a projectile motion question, but you can answer that projectile motion from energy perspective. At the beginning, that projectile motion question, number 5. Tell me, a 0.04 kilogram ball, 40 grams, is thrown from the top of a 30-meter tall building, point A, at an unknown angle above the horizontal, as shown in the figure. The ball attains a maximum height of 10 meters above the top of the building before striking the ground at point B. Air resistance is negligible. The question, what is the value of the kinetic energy of the ball at B minus the kinetic energy of the ball at A? So we cannot solve this from a projectile motion perspective because they didn't give the initial angle. You remember when we have projectile motion, we usually have BO and the angle, and we found BXO and BYO. Here, they want to solve this from an energy perspective. So you have to go by inspection. And you go the following way. We want the kinetic energy at A minus kinetic energy at B. So what do we know from theory? That if delta E is equal to what? What is delta E in this situation if there is no air resistance? Equals 0, right? Yeah. And what is delta E? Is delta K plus delta U, correct? Delta K plus delta U. What we are looking for, if they want KB minus KA, what are we looking for? Delta K. And what is delta K equal? Negative delta U. And what is delta U equal? What is delta U equal? mgy final minus y initial. So will be negative what? mg final, right? So can you see that you only have to learn or know the concept? So in this case, it's easier to work with delta K plus delta U, and you realize that delta K is negative delta U. Now you need to know what is delta U. So with this, we finished pretty much the question related to pendulum. So if you go to question 8. So I'm giving hint just to give like a push. When you do the study guide, you understand the study guide, you at least have certain idea. I hope you are taking notes of the idea and comes with questions to not happen the same that happened before in the previous test. Go over, understand it, come with questions. All right. Number 8. A 12 kilogram projectile is launched with an initial vertical speed of 20 meters per second. It rises to a maximum height of 18 meters above the launch point. How much work is done by the dissipative air resistive force? So they want what will be the work done by the air resistance force on the projectile during this ascent. Which of the 3 theorems? So remember, most of the question will be answered with the 3 theorems. Unless that will be, yes, I give the force, find the change in potential energy. You have to use the concept. I give the force, the displacement is constant, get the work. This will be very simple. But most of the question, when you have to answer complex question, is to choose between these 3 theorems. Which of the 3 theorems you will use in this particular case? Second. Why?
Because the air resistance.
There is air resistance, number 1. And because I could use the first theorem instead of the second, I could use the first because they are equivalent. But it's better to use the second. Why?
Because
They didn't give any specific force. So if they don't give any specific force, no problem. I work with the second theorem. I could work with this, it's equivalent, but it's easier to work with this. Now, what we are looking for the work done by the air resistance, what is that in this theorem? WNC, the work done by the non-conservative force. And it's equal to what? Delta E. There are times where the work done by non-conservative force is the friction. When you have a ramp or something, will be this, which can be found in two ways. Either negative F delta X, if you have mu, or you have the force of friction, you can find it this way. But if you don't have mu, or you don't have the coefficient of friction, you have to find it this way. This. Either way. This or this. In this case, they didn't give the force, the resistive force. They gave the height, but they didn't give the resistive force. Since they didn't give the resistive force, we cannot use this. This will take place of the friction, the resistive force. We cannot use this. We have to go through here. And let's go by inspection. What is delta E? You need to go at the final point, what type of energy? At the initial point, what type of energy? At the final point, what type of energy? There is a resistance. I throw this up. I throw this up. You know that the gravity affects the motion of this. I throw up like this. And I ask, what will be from here to here? What will be the work done by the air resistance, which is the energy released or spent in form of heat by the air resistance. So you can see that if I throw this and this will be two different things with the same speed. You can see if I throw with the same speed, which one is higher? The marker. Why? Why? The mass is not relevant. I mean, if I throw this, what will happen? The same. They have to hit the same at the same time, but not this. Why? A resistance. So I throw with the same speed, the same hand at the same time. Look, it doesn't go the same way because there is a resistance. I am looking for that work missing here, that amount of energy missing here. That's what I am looking for.